Hello and welcome. I thought today I'd go through a bit of a discussion around Databricks, and in particular, Databricks and the use of MLLib to do machine learning inside of Databricks, right? So kind of a relevant topic for our conversations. This isn't some notebook that I created, by the way. It's something I found and borrowed from the good examples there on the Databricks website as well. But I thought I'd work through it to kind of explain and add a little color commentary. So before we get started, one of the things I did earlier before this class is go and create myself a cluster in the Databricks Community Edition. I selected whenever I created it that I wanted the the machine learning version of the image of Databricks, and so this is the 8.2 ML library. You can't create more than one cluster, but I can show you that I selected the 8.2 ML here. Also keep in mind, you can't really seem to create one with a GPU, so it's kind of like a tease or something there to let you know, hey, Databricks supports it, but not for free. Or maybe it's a bug, I don't know. So anyway, so I've got my cluster up and running, and I'm attached to it up here. So you can see that I've attached to that cluster, and again, it's Databricks 8.2 ML, and the kind of the process to start going through, and a couple other little housekeeping things to notice. One of the things that they've added relatively recently in Databricks is the ability to see the outline of your markup or your markdown, right? So inside of your markdown, whenever you create something with a single pound sign, it's considered like heading level 1. So it's like a H1 in HTML. When you create something with a heading level with 3 marks or 4 marks, it's considered to be like 4 levels in. So they kind of nest in underneath these things. They've taken advantage of that fact, they being Databricks, to go through and make it so that you can have pretty well organized notebooks with navigation built in. So you can actually jump down to the pieces that are very much very much the pieces that you might want to take a look at. Really handy. Kind of gets in the way for what we're doing right here, though. But it is a nice thing to keep in mind. So to go ahead and start stepping through this, I'm just holding down the Shift key and hitting Enter. And at this point, all we've done is talk about the kind of where does it come from. So the example here is going to be using naive Bayes, and does do basically kind of a description of the algorithm. Talks a little bit about the data frame based APIs that are used inside this notebook. And there are other versions of it that these are the links to the different languages. Obviously this is Scala. It tells you up here in case you're ever curious what language something is the default language in a Databricks notebook. It's up at the top. But there are versions of this notebook that are available in Python as well. So for those that are using different languages. And also the little bit of a few links here to kind of go out if you want to learn more about pipelines in general. And then you probably don't want to be doing anything with RDDs unless you really have to. There's benefits to not going down to that level. You're better off sticking with the data frame sort of level for lots of reasons, one of which is actually performance. It is done better, they're a little better now than going down to RDD in certain circumstances, especially when you start considering things like caching. So the data analysis example is to basically start off by doing a review of the data set, loading it, exploring it, then you create a multi-class classifier and then classify and evaluate. And then experiment with various smoothing parameters. So the data set that it's talking about in this example is our good friend Iris, one of the more popular and very frequently used examples, very old, but also quite interesting. As you'll recall, it's about classifying a type of iris into the 3 sort of types that they are, or species. And so there is a target label, which is the species of interest. So to load the data, it's actually so common that it's built into the data sets that are available to you, pretty much just there inside of Databricks. So you can take a look. All this is doing is calling display, so it'll print it out in a reasonably pretty way, potentially. A file system ls, so basically dbutils allows you to access utilities, essentially, inside of Databricks, including the file system, so the Databricks file system, and allows you to do things like an ls, which is the equivalent of a DOS directory. So all this is doing is going out to that location and looking for that file. And it returns back the reason it's in this nice little grid is this display command, and you can see the path, the name of the file, and the size. And so it's not real big. The next step is going to be to essentially read it in. One of the things that is very convenient inside of Databricks is that it does have the ability to use a table construct, very similar, I guess, to Hive in a lot of ways. But the lines between the data frames, tables, and so on are purposely kind of blurry, right? So in this case, what we're doing is creating a table called iris with the columns that correspond to the columns inside of it, including their data types, so ints, doubles, and strings. And we're using this essentially CSV library, for lack of a better word, and then we're telling it here's where it comes from, and that it does include a header. And then the last statement is if after it has created that table is to select from it. And so we've got the table out there backed by a file that we can interact with using essentially SQL, right? So a very cool sort of way of doing this stuff. And we don't really care about some of this stuff. So instead what we're going to do is select the stuff we do care about into a data frame from that table. And again, this is kind of just showing you that you can mix and match the type of tools that you want to do. You could equally well have created a data frame directly from this CSV. Nothing would have stopped you from doing so. This is kind of showing off, hey, look at this. We can create a table from a file, and it's really easy. So now we've created this data frame by selecting only those columns we care about. We don't care about the row number. It doesn't add any value. So we've got the sepal length and width, and the petal width and height, or length and width, and then the species. So we can take a look. What does that look like? And so we can display the data frame into this nice little grid again. And as you recall, or maybe not, maybe I haven't said it before, but you can do visualizations inside of this stuff. So you can take a look at the various types of things in addition to just looking at it as a grid. So kind of a cool, simple sort of data exploration. It's not going to put Tableau out of business, but it will make it pretty easy for you to get a sense of the data pretty quickly. One of the things that you have to do whenever you're doing lots of these types of classification is oftentimes convert from categorical values into numerical categorical values. So in this case, you're converting our label to the actually a numeric category, and that's what this string indexer will do for us. Is we're basically binding it to a particular column, and we're setting what we want to output. And all this is doing is kind of setting it up. It's not really doing anything just yet, but we're just kind of getting it ready. So one of the common things you'll often do is you want to take a look at the schema. So do some sort of kind of visualization of it. You can also, this particular one, because it's showing kind of the relationship, may actually look better with a print schema than it would dumping it out into with a display command. Then you may want to do some simple charts showing the various, and this is because we've modified this stuff over here, showing essentially the histogram, right, of the various values along the way. And so it gives some indication of the ranges and so on. The next step is typical with any kind of classification or machine learning in general, is splitting the data into a training set and a test set. Idea being that you don't want your algorithm to have seen what you're testing it with so that maybe it does really good because it's seen it before, right? So instead you take some of your data, you hold it back so that it's something that is new to the algorithm, but yet is kind of enough that you've got enough data that you can actually do the training and kind of figure out what's going on. So once we get into here, we're basically doing that. We're on the iris data frame. We're saying do a random split along the lines of 70-30, so 70% for training 30% for test. And then we're specifying a random number seed so that while it's random, it's reproducibly random. So the seed basically controls when the algorithm, where it starts from. So you want it to be predictable oftentimes so that we get the same results each time we run it. If you were doing this for real, you might not have a seed because you may want it to be truly different each time you run it. We like it to be the same, otherwise our results get kind of interesting. So how do you know if you got it right? Right, so in this case we went through, we're creating essentially two different arrays of data. One will be training, one will be test, and that's what's coming back from this function random split. Then because we're going to use this data more than once, we want to cache it, right? And this is potentially something that may be a little different, but by calling cache, we're basically telling Spark, hey, you're going to see this again, so we would like you to cache it. It's a recommendation. It may or may not really take it into consideration. Things do what they want to do, but generally speaking, it's a good idea to, if you give it the hint, right, that hey, this is something that should be cached. Likely will be, but with most things, who knows. So your next is to go through and actually do this vector assembler. And what this is going to do is merge your columns into a single feature vector, essentially, or a single vector. And that vector is going to be passed into the naive Bayes algorithm. So we use this vector assembler, and we're basically, again, we're just creating the thing that is going to happen. We're outlining that we're going to do this, but we're not actually doing anything yet. We're basically kind of just setting up these pieces that we're going to use. Then we're going to want to create a naive Bayes classifier and give it those 4 features so it can do our predictions. So we import it from the namespace Spark ML classification naive Bayes, and then also pipeline, and pipeline's an important thing because that's actually going to be in MLLib. That's how it kind of does its thing, is you outline the things that you want to happen in the order that they happen. So they become essentially stages in your pipeline, right? And then you run the pipeline. So in this case, what we're doing is we're setting those stages, and to kind of go through this in a fairly slow, we're creating this naive Bayes classifier. So that's what MB is. And then what we're doing is we're setting the stages that need to happen inside of this pipeline to where the first thing we're going to do is do the label indexer, then we're going to do the vector assembler, which is what we just talked about up here. And then the last thing we're going to do is use that naive Bayes classifier and actually do it. And then whenever we get this pipeline defined, nothing's happened yet, really. We just said what we would like to do. Now we say create a model that's from that. And so at this point, we basically are outlining what we want to happen in the stages we want it to happen, and we're telling the pipeline to fit the training data. The interesting thing with Databricks is that, and Spark in general, is that it is lazy in the sense that it does lazy evaluation. So it's sometimes challenging to know exactly when something is going to run. And it did run, it looks like, whenever we actually did this fit up here. And so now we're making our predictions and getting back the schema. We're showing the schema of the predictions. And then now we're going to display those predictions in a somewhat easier to understand format. And then the next step, as with most things in classification, is to evaluate the results. So how did we do? And that's where we use a multi-class classification evaluator to see how well we did. And so it's essentially going to take the predictions and evaluate them and determine the model accuracy, which in this case is right here at 0.913, so right around 91% accurate. Not too bad, especially given some of the challenges that can happen with the IRIS data set. So one of the things that you do have this ability to do is to create or replace a temporary view. What that does is a temporary view is like a table in a sense, and what you're doing is making it to where it'll be available to you from inside of this SQL statement down here. And sometimes it's easier to express the things you want to do as SQL than it is to actually write them in some sort of other mechanism, right? So what this is doing is creating that temporary view, and then what we're doing down here is creating inside of Python. So we're splitting out to Python. This is a magic cell. And part of the reason we're doing this by creating this temporary view is that we're crossing language boundaries. So the context is slightly different. One of the things that you can do to access data from different languages is to do temporary views along the way, or tables, but basically something that goes out to the SQL system, right? And so what we're doing is we're inside of Python creating a data frame that is the predictions, and then we're going down to the actual RDD level here because we need to, in order to do this confusion matrix, because the confusion matrix is something that's only available on this multi-class metrics library for whatever reason. So that's the reason for all this last little bit, is that we want the confusion matrix. You can't seemingly do it inside of Scala, but you can do it inside of Python. And it's not that you can't do it inside of Scala. You probably could, but you'd have to go down to this RDD level and find the multi-class metrics and so on. So that's the point of this. And the whole point of doing that is, as you recall with classification, one of your means of evaluating is to determine how many were misclassified and in what way, recalling that the diagonal is the true classifications, and the other ones are whenever it was misclassified and how many of them are misclassified and what's the nature of that. So with that, I've kind of walked through doing MLLib inside of Scala, inside of Spark. Not a mind-blowing sort of experience, but hopefully beneficial. As always, if you have questions, let me know. Stay safe, and we'll speak again soon.